Assalamualaikum warahmatullahi wabarakatuh. I am Azreen, AS10626. Today, I am going to explain about transmission of nerve impulse. Before I start, let me introduce my model first. As you can see, the green particles are sodium ions, while the orange particles are potassium ions. There are two types of gated ion channels. The green one is the gated sodium ions channel, while the orange one is the gated potassium ion channel. So let's start with the further explanation. For your information, there are two types of membrane potential, which are resting potential and action potential. Resting potential is when the axon is not conducting an impulse. As you can see in the model, there is a difference in ion distribution on both sides of the axonal membrane, where there is a higher concentration of sodium ions which is outside the axon, and there is higher concentration of potassium ions inside the axon. The unequal distribution of these ions because of the sodium-potassium pump. The pump is an active transport system in the plasma membrane that pumps 3 sodium ions out of the axon and 2 potassium ions into the axon. Because the membrane is more permeable to potassium than to sodium, so there are always more positive ions outside the membrane than the inside. Then, when you connect to a voltmeter, it shows that the resting potential is negative 70 millivolts in the cell. Next, I will explain about the action potential. Action potential is a rapid change in polarity across the axonal membrane when the nerve impulse occurs. Action potential has two stages, which are depolarization and repolarization. These stages involve two gated of ions channel that I mentioned earlier, where the gated sodium ions channel will allow the passage of sodium ions, and the gated potassium ions channel will allow the passage of potassium ions. So, when a neuron receives a signal from another neuron, the gated ion channels will open and close in order to respond to the stimulus. The threshold is the minimum change in polarity across the axonal membrane. So, if the threshold is reached, you can see in the model that many more sodium ion channels open and causes the sodium ions to enter the neuron. As a result, the inside of the neuron becomes more positive. It means that the depolarization occurs. As the sodium ions rapidly moves across the membrane to the inside of axon, the action potential swings up from negative 70 millivolts to positive 35 millivolts. However, the reversal in polarity causes the sodium ion channels to close while the potassium ion channels to open. As potassium ions leaves the axon, as you can see in the model, the membrane potential swings down from positive 35 millivolts just now to negative 70 millivolts. In other words, the repolarization occurs. So that's all from me. Thank you.